I'm keenly aware that I am the person standing between 100 people on happy hour, so I'm going to try to make this fun and quick. All right, so my talk is all about creative coding. And my goal for this talk, and we'll revisit these goals at the end, is to convince you of a few things. One is that you can build almost anything on the web. And put another way, I think it has recently become the case that creativity is as much of a bottleneck as to what you can build on the web as technology is. That cool things are always just an accumulation of simple things, and that the best ideas come from play. Okay, so quick introduction of me. I had a pretty traditional computer science background, went to the University of Maryland, who I think are starting their first March Madness game in a few minutes. So if anybody checks the score and sees that they're losing, keep that information to yourself. It'll mess with my psyche. Spent the first 6 years of my career working at big tech companies. Then around the pandemic, I had a little bit of a quarter life crisis or a 1/3 life crisis. I just wasn't sure if I wanted to do software engineering for the rest of my career. So I felt a little bit jaded about coding. So I got together with a friend of mine who was feeling similarly, and we're both huge sports fans. So we just started coding stuff around our hobbies. So we made this data visualization website that was geared around basketball data and sports data. And that was a pandemic passion project. And that springboarded me getting the job that I have right now at a small company called Cleaning the Glass, where I'm actually working with NBA data for a living. And kind of alongside that, the last few years, I've gotten really into the world of creative coding. So I think creative side projects have really kind of shaped the last few years for me. Okay, that begs the question, what is creative coding? So I think if you ask 100 different people in the space, you'll get 100 different answers. My simple answer is that it's coding that is not strictly utilitarian, right? So oftentimes for work, we're building functions and building apps to solve very specific problems, to make a lot of money usually. So I think creative coding is the broad umbrella of things where that's not the main goal. So it could be artistic and expressive. I think this is more the space that I operate in usually. But it can also just be kind of fun and pointless. And to prove that, I think this is the example of the creative coding project that has gone the most viral this year. So if you're not familiar with it, it's a website that is essentially a shared canvas of 1 million checkboxes, and anybody can go on and start checking and unchecking boxes, and that's the whole website. And I love that the New York Times described it as an unintentional case study in human behavior. So yeah, my creative coding journey, a lot of it's centered around this JavaScript library called p5.js. P5 is a port of a Java-based language called processing, and it's built on top of the HTML canvas. So over the last few years, Skoon very nicely mentioned that I've worked on projects around music, mindfulness, data visualization. The cool thing about creative coding is you can really apply it to any of your interests. I have friends that do creative fitness projects or really whatever you're interested in. Soon after I started creative coding, I started sharing my projects with the community. I think these days I'm really drawn to small communities of people sharing work, but early on I was really excited whenever I went viral on Reddit or HackerNews, which is a double-edged sword. And yeah, I'm still going strong. That's why I'm here. And why I'm passionate about it. So who here has heard of the word enshittification? Okay, most of us. So it's this word that, it was actually the American Dialect Society's word of the year in, I think, 2023. And it's this word that describes that, the gradual degradation of services over time. And I think a lot of people use it to describe the web. So I kind of think about it imagine, you're transported back in time and you can talk to your ancestors who are communicating with, stone tablets or papyrus scrolls or something, and you show them your phone, which is this thing that can magically update its contents based on what your friend is doing from around the world or based on access to all of human knowledge ever. And just the fact that we like use this to kind of scam each other and advertise to each other is kind of a bummer. So I'm a big proponent of the web being weird and creative. I think visual coding is a really incredible way to learn coding. I think we're starting to see that with like Scratch being the main way that early CS education is taught to kids. Something about like the feedback loop of just like writing a line of code that says like draw a circle and then you see a circle. It's just the mental model really works well. And lastly, this is like the utilitarian part, I guess. I do actually apply a lot of the things I learn from my creative coding projects to my job. Whether it's like creatively finding a way to visualize data or what have you. All right, so the bulk of this presentation is going to be a series of demos. No need to take notes. I'll share the link at the end. Okay, so I set up this gallery that essentially has three parts. There's like a navigation here full of our 30 sketches, and sketch is just like a colloquial word for a P5 program. This big middle section is what the code is actually drawing on the screen. And then on the right here, we have sort of the key code snippet that the sketch is introducing. And below that, there's a little link here where you can actually run this code and tweak the variables and experiment with it. So the idea here is that these 30 sketches all build on top of each other, and we'll show that we can make some pretty interesting things by just combining simple concepts. So this first one is the most simple thing you could do, is just to draw a gray background. The main takeaway from the first sketch is that there are two functions in P5 that are really important. One is setup. That gets called once at the beginning of your project, of your program. And the other one is draw, which will run at, by default at 60 frames per second. Here, since this is a static sketch, I called the no loop function, which will make it so that draw is only called once. So we have setup and draw. And besides that, I'm calling this create canvas function to initialize the canvas element on the DOM. And then I'm just calling the background function to set it to this gray color. OK, not super interesting. This sketch draws a shape on the screen using the ellipse function. And the ellipse function takes in coordinates. So here I'm passing width over 2, height over 2 to place it in the center. And it takes in a size. So I'm giving it a diameter of 200 pixels. We can style our shapes. So in this sketch, I fill it with this nice pastel-y red color. And I call no stroke to get rid of the outline that was there before. So that's the outline. It's gone. OK, so naturally, we might want to draw lots of circles. So one way we could do that is by systematically placing them in a grid. So this code is using a doubly nested for loop and calling an ellipse function and positioning it based on its sort of index in the for loops. So a little bit of math here to get the spacing right, but not too bad. OK, this is a little boring. They're all red. So this next sketch pulls in a set of 8 pastel colors, and it calls the fill function using this modulo operator. And it's essentially going to assign a different color to each circle based on its position in the grid. So you get this kind of nice, cool, like diagonal effect. OK, so that's like kind of systematically placing shapes. Sometimes it's more interesting to randomly place shapes. So that's what we're doing here. So this code is looping 800 times, drawing 800 circles. It's randomizing the position of the circle on the canvas. It's randomizing the color. And it's randomizing the size from 10 to 60. So this looks a little bit more artistic. One cool thing we can do is add transparency. So we get this nice layering effect where you can see that some are kind of on top of the other. OK, so that's like true randomness. But sometimes we want like randomness with constraints, or like smooth randomness. And that's where noise can be really helpful. So imagine you're trying to procedurally generate terrain for a game or something, like a map. That's where you'd use the noise function. So what this sketch here is doing is it basically sets up a 25 by 25 grid. And it's calling this noise function, passing in basically the position of the grid. And this returns a number from 0 to 1. And what I did just to make it easy to display is I multiplied it by 100 and took the floor. So what you'll notice here is that each number, the neighbors around that number are all values that are very close to it. So it's not truly random. It's a more smooth random. So this sketch color codes it. It just draws a rectangle behind each one just to kind of visually show this pattern. So you can see that there's like the section up top is a little lighter and the section on the bottom left is a little darker. We can also increase the resolution of this. So this is the same idea. If you zoom in, you can see the numbers. But this is 100 by 100 instead of 25 by 25. And now you can start to see that this looks like a thing, right? Like you have these dark blobs here, this big white blob in the bottom left. And so now we can do interesting things with this pattern. For example, we can discretely assign colors to each grid cell based on what the value is. So that might look like this. Where here we essentially took every value that was 0.4 or less given by our noise function and assigned it this blue color. And if you're between 0.4 and 0.7, you're green. And if you're higher than that, you're this like light brown color for mountains. So this is starting to look a little bit like terrain. We can also make the colors smoother. So this sketch is introducing the concept of linear interpolation. So essentially what we're doing here is we're saying you're still water if you're less than 0.4, but the shade of blue is determined by how low your value is. So we're interpolating from this dark blue color to this lighter blue color. Oh, sorry, the scroll is not great, based on the elevation value. So this looks a little bit more, I don't know, detailed, I guess. We can pretty easily make the noise function look more zoomed in or smoother simply by changing this constant noise scale. So going back to our original noise sketch, we have this noise scale constant that we're multiplying for the arguments in the noise function. So just changing that one parameter gives us like a super zoomed in view of the terrain. And conversely, increasing that value gives us a more zoomed out version. And we can also combine a lot of these principles, and this is kind of what I meant by play, right? So we've talked about randomness and we've talked about noise. What does it look like if we combine those concepts together? So here, instead of drawing the rectangles neatly in a grid, I'm drawing essentially random circles where the color is still based on the noise, but the size is random. And I also added a little bit of a jitter here so that it's not like each circle is kind of a little bit offset from its true position in the grid. All right, halfway there. Okay, so we've talked about systematically placing shapes. We've talked about randomness to place shapes, and we've talked about noise to place shapes. The other kind of main positioning logic that I use in my projects and in my work is using data to actually inform where the shapes go. So here I pulled cherry blossom data from the EPA. And essentially what I did is each data point has a year and a peak bloom, which is a number that is essentially like how many days into the year peak bloom was. And I essentially set it up so that the circles are, the more recent years are on the right, and then the years that had later bloom dates go up. And sort of the magic here is this map function that P5 exposes that essentially lets you like pass in any value and map it from one domain to another. So here I'm saying take the year, the min year, and the max year, and then give me an x value that I can actually plot on the canvas. And then I do the same thing with the y coordinate. So now we have a bunch of circles whose position is based on real data. Not a great chart if we don't add some axis lines. So we can use the line function in P5 to draw our axes. So these first two lines are just drawing the x and the y-axis. And then it's a little bit of a hassle, and like P5 is not the best language to do data visualization in because a lot of JavaScript libraries will do this out of the box, but if you want like super customizable and super performant data visualizations, P5 is actually a pretty good option. So yeah, we're drawing these axis ticks, these little lines in for loops here. Next, we can use text, just using the text function here to kind of add more context to our data visualization. So when do cherry blossoms bloom in DC? Year, peak bloom date. Really the only interesting thing happening here is this rotate function to make our y-axis rotate at 90 degrees. And then what I did here in this next sketch is I essentially faded the ellipses, the circles, for the data points. I calculated a rolling average just using vanilla JavaScript. And then I used this curve vertex function to essentially draw a trend line through my data. So what you can see here is that it's getting earlier and earlier. OK, so all of these sketches so far have been static examples. One really cool thing you could do with P5 is add animation. So this is a simple example of like a rudimentary physics system in P5, where essentially I have these 9 circles, and I'm assigning a random velocity to each one. And every frame, I'm increasing the velocity, the position of the circle based on the velocity. So very similar to the game development talk earlier in the day. And then if we detect that the circle's position is up against a boundary, we just reverse the velocity so that it's going in the opposite direction. This is an example of how we can animate a single shape. So I'll hit this show waveform function here. So in this sketch, we introduce a variable t equals 0 to represent time. And we're increasing that by a small amount every frame. And then we can essentially pass it into a function that will give us a value between 0 and 1. So I have 3 different waves set up here. And then based on that value, we can use the linear interpolation we learned earlier, along with this map function, to essentially go from like small and blue to big and red. So this is a triangle wave. This is a sawtooth wave where it's going to be like a very sudden change. And this is a sine wave. This is an example that is kind of combining a lot of the ideas that we've looked at so far, where each circle in our grid is doing what the last sketch was doing, kind of pulsating from small to big and changing color. And then you get this nice little ripple effect because I offset the like where in the animation it is based on its like distance to the top left corner. So it looks like it's like kind of pulsating out from the corner. So pretty interesting. This next sketch is showing that we can apply the animation principles to the terrain example. So here, essentially what I'm doing is I introduce an offset variable that I update every frame, and then I'm just adding that to what I'm passing into the noise function. So this looks like kind of like you're flying a plane or something. OK, the next set of sketches here are all about interaction. So we can implement some like mouse events in P5. So here we implement the mouse press function. And essentially what we're doing is if we detect that the mouse is pressed inside of the circle, we initialize some state to animate a ripple. So this reminds me of like the Staples easy button. We can also implement hover logic. So here's our colorful grid again, and I added some code here that will essentially check the distance between the mouse cursor and each circle and apply a stroke to that circle based on how close it is to the mouse. So you can see that the one that I'm hovering over is like big and bold. And at 60 frames per second, this is like a pretty nice spotlight effect. P5 is pretty good for making drawing apps too. So here's an example where if I move my mouse, I'm drawing these transparent circles. Really, the only key for this one is that the way Canvas works is it essentially draws each frame on top of each other. So you want to be careful that in your draw loop, you're not resetting the background, because then you'll lose the circles that you've drawn already. So that's fun. Back to our terrain example. We can implement some key pressed and key released logic to essentially apply the offsets based on like WASD keys. So here I'm piloting over infinitely generated 2D terrain, which is pretty cool. All right. And then the last set of sketches here are just like other random cool things you can do in P5. So here I built a little like toy synthesizer where if I click on a note, if I click on a circle, it'll play a note. And I also hooked it up to the keyboard, so play some notes. And so this is actually using another library called tone.js, which is really great for if you need to do any like browser-based synthesizer stuff, or JavaScript is like notoriously bad at syncing time, but tone.js will help you with that. P5 also has a WebGL mode. All you need to do is pass in the WebGL option here. And in this sketch, I essentially am using the same exact code as I did for the 2D terrain, but I'm also setting the height of each sort of grid cell based on that value. So we have 2D terrain. And the WASD keys here also work. And what's cool is like this is all less than 100 lines of code. So I definitely encourage you to pull it and check it out. And the last one, which might be my favorite, is you can actually hook into your webcam using P5. So here is one where I am waving at my screen and making art. And I also made an ASCII mode, because why not? So yeah, this one is actually, it's drawing a grid, and it's detecting which pixels are different frame by frame, and trying to detect motion, essentially. And again, this is less than 100 lines of code, which is so cool. OK, that concludes this set of demos. I think I have a couple minutes, I'll show one of the projects that Skoon was talking about. So this is a project I built called drawbeats.com. It's essentially a music synthesizer where you can just open it and start like dragging over it to make some notes. The purple section represents melodic notes, and the green section represents percussion. And then you just hit play. Not the best, but not bad. And then there's all kinds of settings where you can like increase the tempo. You can make it swing. You can change the instrumentation here, so there's like a little chiptune mode. And all kinds of other settings. So the sort of technical stack for this was I used P5 for the actual like sequencer pads, and then rendering these little ones on the preview. So the way this works is if you share your pattern, it'll be public, and you could see it on the feed on the left. So I use P5 for that part. I use Vue for the overall web page. I use Tone.js for syncing the audio, and then I use some like Heroku Flask backend for the sharing. The one funny thing about this project is I found out a couple years ago that there were some like elementary school kids that were starting to use this, because I guess it's like a good music ed thing. You don't have to like buy software. You just open this website and start making music. But when I found that out, I realized that there were people that were drawing like pretty lewd things on the side panel, just with like a 16:8 or 32:8 grid. So I had to set up this whole system where I could audit things before they showed up, so that the little kids wouldn't see them. So you do run into unexpected problems in this space. But yeah, that is one of my passion projects. OK. But that was a lot. Thanks for bearing with me. So yeah, just to revisit our goals. You can build almost anything on the web. I really do think that we're converging to the point where creativity is as much of a bottleneck as technical constraints. Hopefully you saw that like to get to sort of those last few sketches, they really like built on top of each other. Once you like learn how to draw a circle, you can learn how to animate it, and then once you learn how to animate it, you can like make it play a note, and it really is just a snowball of things like that. And yeah, I really encourage you to check out the sketches, and just if there's one that you're excited about, just open the code for it and start changing some variables and seeing what happens. All right, here's a link to the demo and my blue sky plug.